My name is Gulshan Banu, working as an assistant professor, AI and DS department, SNS College of Engineering. In the previous lectures, we saw what is neuron is and what is deep learning, what are the different things that is related with deep learning and why do we need deep learning, the applications, the neurons and the correlations of neurons with the neural networks, right? Now in this video, we are here with a new topic from the Unit 1 Introduction. The topic that I am going to take today is linear models. Now, what is a linear model is? The English term linear itself is, it has a single process that is called as a linear, right? So models is something that you have to work and you have different kinds of data and different kinds of process that is being involved with it, and you will get one single result from the given amount of data. Now, this linear model, it actually generates a formula by itself, and it will fit in the best one, predicting the unknown values. Okay. Linear models are not predictive as new algorithm classes, but they can train relatively quickly and it can generate some straightforward data based on it. As in the diagram, it explains the linear model in which it has a different kinds of data that is associated with it. The data points are given in blue. The red line is the best fit which the model generates, and it captures the directions of those points. Now, why do we use a support vector machine? Support vector machine is one of the model which comes under the linear model. It is one of the most supervised learning algorithms. We know what is supervised learning is, and it is one of the things which is classified under a regression problem. Now, however, we'll be primarily, it is being using in for the classifications in machine learning, which is you will have to classify different kinds of data, right? For those process, you will be using this supporting vector machine. So the goal of SVM algorithm is to create the best line or decide the boundaries that are segregated in and around based on it. This best decision boundary is called as an hyperplane. That is the thing which we are using is called as an hyperplane. The best decision, from that best decision we will be using some process. Hyperplane will be created with a minimum margin, which also means the maximum distance from the data time. These extreme cases are called as support vectors, and hence the algorithm it is termed as a support vector machine. Now, what is this support vector is all about? The data points or vectors that are closest to the hyperplane and which affects the position of the hyperplane are termed as the support vector. See, in this diagram it has been noted that you are having different kinds of data, and that x into w plus b equal to 0 is the input value and the miscellaneous value, and since we are denoting it with a straight line, we are using a straight line formula for it. So you are having a maximum margin, you are having a minimum margin, you are having a positive value and a negative value. Based on those things, we are correlating it and getting a linear value, which is the correct value or the same values which is being executed. Now, see in this diagram, as I we are just having the discussion, right? So in that you will be given those labeled data. Okay. Now we have to train and we have to predict based on the linear value model. Upon that, you will be getting the output as it is either dog or cat or something which is based on it. Now, where do we use these support vector machines? It is used for classification as well as the regression problem. Primarily used for classification problem in machine learning. The goal of SVM algorithm is to find out the best decision boundary. Okay. Now, where do we use? For example, it is being used in face detection, image classification and text recognition. Now we will see what are the different types of support vector machine. One is linear SVM and another one is non-linear. Linear SVM is nothing but you have different kinds of separable data over there, and non-linear SVM is you can't separate the data actually, and prediction is quite difficult for it. Now this is the example of how linear and non-linear actually is based on. In this non-linear, you have different data assigned with different kinds of process, and it is quite difficult for us to determine. Okay. So these are the basic concepts of how linear model is, and how it is being executed, and what are all the different kinds of process that is related with the linear model is. We saw what is linear model and what is the types and what is the use and where we are being used. All these linear models is all about. So in the next video I will be definitely meeting you with the different topics. If you have any kinds of doubts, please comment in the comment section. As of now, I hope that you understood these topics, and I'm signing off. Thank you. Have a good day.